A bell ringer is a time for you to talk with people to make sense out of this, even if you don't fully understand it. Come on, head up, Marshall. So don't sit there and talk about non-math related things. Talk about it to help each other learn. Thank you, Tyson. Sorry for closing that door on you. All right. So, first off, we got to remember, okay, when I look at a square root, what does a square root ask? Like, what does that operation really mean? What was squared, right, to get that number? That's it. So, first things first, what do we have to have so that when we square it, we get a negative? What do you have to have that could get squared to get a negative? Because if I take it, let's say I take -7, right? And I square it, what do I get? A positive 49. Because remember, that's -7 times -7. That's a positive 49. So what do you have to square in order to get a negative? Say again.
Imaginary number.
An imaginary number. What's the imaginary number? I. Well, the square root of -1, but what do we use to represent the square root of -1? I. Like as soon as I look at square root of -49, I know there has to be an I involved. Now what's the square root of 49? What squared gives me 49?
7.
That's it.
What do we?
That should have been our answer. Hold on one second, Aisha. So I want to point this out. Remember, what squared, right, gave me a -49. If I square 7i, what's 7 times 7? 49. Then I is literally squared, and what is I squared? This is that defining characteristic. Still up here. Mathematicians defined it so that I squared is equal to -1, and 49 times -1 is -49. That's it. Okay? That's all we're looking at. Now, I do recommend a slightly different approach because that works great if you're dealing with something that would be a perfect square. When I look at the square root of -49, to simplify it, I first off always know that if I'm taking the square root of a negative, I want the square root of a -1. I start there. -1 times what gives me -49? 49. Don't make it more complicated than that. I'll show you why I do this in a second. But remember, a square root has a special property that you can actually split up that radicand when you're multiplying. And this can make things easier. By definition, what number is the square root of -1? Square root of -1. Not -1 squared. Square root of -1. What squared gives us -1?
I.
There we go, right? The whole point is, by definition, I squared, you cannot forget what a square root means. You cannot forget that the whole point, here you go, Jalen. The whole point of a square root, or the whole point of I, is that I squared is -1, so the square root of -1 is I. Square root of 49 then? 7. Or 7i. Same exact approach here. The reason why I do this is because of the second question I had on here. The square root of -45. Is there a perfect number that when I squared I get 45? No. Are there any factors of 45 though that I can easily take the square root of because they're a perfect square? Shania? You engaged? Shania?
Sorry.
You with us? Can't zone out. We're going to learn. Rakai, you focused? Okay. Guys, one factor of 45 that would be, I can take the square root of because it's a perfect square. 9? So this square root of negative 45, first off, what number do I want to, what factor do I always want to use when I'm taking the square root of a negative? You always want the negative 1 because what is the square root of negative 1? It's I, right? I need that square root of negative 1. So I'm always starting with negative 1 times. What's the factor of 45 that I can take the square root of easily? 9 times, what's the last factor so that I get negative 45? 5. That's it. Negative 45 is negative 1 times 9 times 5. And I did that because I want a perfect square. This is how you simplify square roots. Square root of negative 1 times the square root of 9 times the square root of 5. Square root of negative 1. I every time. Square root of 9. Square root of 9. 3 times. Do I know what the square root of 5 is? Nope, it would be a nasty decimal, so I leave it as square root of 5. That's it. And you can rearrange it. Typically we put that 3 first, then the square root of 5, then the I. That typically comes at the end. But not sweating it. You can also rewrite it as 3I square root of 5.
Do it back.
It doesn't matter a ton. Typically, we put the I at the end here. The standard format of complex numbers, so when you have an imaginary number with it, the standard form is A plus BI, where I is the last thing written. So you have your real and then the imaginary. That's why this is standard. But it's the same number. Okay? So we're going to get some practice with this today. Especially because based on our understanding checks yesterday, we need some practice with this. Okay? And so here's what I'm going to do to help you account for this. Alright? Since y'all had less time than students yesterday. So we got to remember why we are here. Our education is important because what are we trying to do? Develop arguments. Grow. Learn how to think, learn how to socialize, learn how to learn. Like, these things are important skills, and we're doing this through mathematics, but we've got to develop these skills, okay? Your education matters because we are developing not just content knowledge, but skills. So we're going to finish up lesson 6 from the book, all about imaginary solutions to quadratic equations. And then y'all are not going to have the full 50 minutes, 51 to 70, but I am going to give you your understanding checks back for about 10 minutes for you to update based on the stuff we work on today in class. Felt like that was fair. And then we're going to go over questions from the understanding check and start reviewing for the test. Now, yes, Jalen? Okay, so you'll have the amount of time that everyone else does, just won't be able to fully finish it. We're going to go over it, and remember, whatever you score on the test will replace this understanding check grade. So, here's an option I have for you. Tomorrow, we can either take the test during the first half of class. Tomorrow's test is legitimately just a front and back sheet. That's it. There are, I think, 3 free response questions, short answer questions. There's a couple questions, I'm not going to lie to you. There will be a couple questions literally just simplifying radicals like this. The majority of it is, though, here are 8 quadratic equations. You choose 6 of them, and you have to use each of the solving methods, right? Factoring with zero product property, getting the vertex form with inverses, and using quadratic formula. You have to use each one once, and then you solve the other 3 however you want. Okay, that's your test. That's it. It's front and back. You have 45 minutes to do it. The second half of the block, we will start on our next unit. That's option 1. Option 2 is we review for the first half of the block tomorrow. We start the next unit during the second half of the block, and you take the weekend to study and come in and take the test first thing on Monday.
Yes.
Monday option, raise your hand if you want the Monday option. The Monday option happens. the majority of us who are not raising our hand for the Monday option, I have faith in your abilities to be successful no matter what, so I'll let the Mondays happen. But that actually means that you need to take advantage of studying, because if you don't look at it over the weekend, everything we talk about over the next block and a half is going to empty out your brain. We took 5 days off, and I looked at our understanding checks, and we acted like we had never solved a quadratic equation before. It ain't funny. It was rough to look at. So lesson 6 out of the book is where we are. Let's get our textbooks out. We're looking at page M1-something, 90-something, I think. By the way, if you left a textbook in here underneath the desk, they got moved around. There's 4 of them sitting over there because I had to move desks to other rooms for the ACT, which I know we had a blast with. Okay. Yes, ma'am. M1-93 is where lesson 6 starts. Blush. Yeah. Okay. Today, for the purposes of vertical surfaces, Tevin, why don't you join group 7 when we go to vertical surfaces? Miracle, join group 6. Does that make sense? So Joseph, when we go back there with Naisha. Okay. And so Joseph, when we go to vertical surfaces, we'll go to those groups. Sound good? Yes, Mr. Kenny? Great. I'm glad you're on board. Okay. So remember, all that lesson 6 is adding on to what we've already studied is the idea of what if we have imaginary solutions for a quadratic equation or imaginary zeros. And so this is on page 96. All right. We define the number I. Remember, the whole issue that we ran into was if I take a positive number and square it, what do I get? A positive number. If I take a negative real number and I square it, I get a positive number. And so the idea is I need something that when it's squared gives me a negative. So mathematicians defined what number so that when we square it we get a negative. I. I squared is -1. That's the whole thing. I squared is -1. And we have to be careful about that, right? Jamarcus asked the question earlier, is I -1? And that's the most common mistake that students make. I is not -1, I squared is -1, so that I is the square root of -1. You have to keep that in mind. Everything else is a struggle if you do not remember that I squared is -1 and that I is -1. And I will also remind you, anytime I focus heavily and talk through conceptually, hey, this is really important, there is something involved with that on the test. For example, I already told y'all point blank period, zero product property will show up on your test in some way, talking about it, explaining it. You got to understand it. The imaginary number I is a foundational part of mathematics. You got to understand it and be able to talk about it and talk about why it's important. So from there, we talked about graphs like this. How did we know, this is on page 96 as well, but how did we know that this graph had imaginary zeros or roots? It does not intersect the x-axis. If the graph intersected the x-axis, the roots would be real, right? If the graph intersects the x-axis, the roots would be real, right? Here are my real roots. They could be rational, like R1 right here is 2, or they could be irrational. I'm going to say maybe the square root of 42. I'm making it up. But you can have real or, you can have rational or irrational. Now, technically that can't happen. If you have one rational root, the other has to be rational. If you have one irrational, the other has to be irrational. Don't sweat that. I'm not testing you on that fact. But we then started looking at these. Right? This is skipping to 6.5. This is on page 106 where we're getting practice with solving quadratic equations. Okay? We took the time to graph these, but they're also on the board, and the main thing is, what do we know about the should not say solutions, we should say zeros here. What do we know about the zeros of the three functions? They have to be what? Somebody. Come on, your active collaboration is a part of this. You thinking through it. 106. You thinking through it is an important part of your learning. What has to be true about the zeros for these three functions that they give us in the book? Say it again, Ethan. They're imaginary. Jose, how do we know they're imaginary? They don't intersect the x-axis. You knew that instantly, so why not share that idea right away? Come on. We've got to recognize those graphs are not intersecting the x-axis. They have to have what type of roots? Imaginary. I will point this out. On your test, you'll have a graphing calculator. And on your test, I'm telling you right here and right now, there's a requirement that you solve 2 quadratic equations, right? I'm giving you 8. 2 of them have to have imaginary zeros. Well, how could you check to see if they have imaginary zeros? Do you know how to graph a function? Yeah. So take advantage of that. You can very quickly see if they have imaginary zeros or not. Okay? I'm not going to test you a whole lot on the sum and difference of squares. We talked about that yesterday, and we'll come back to it if we have more time later. But I do want to point out, when I looked at this function, we talked about this function, what do we know about g of x right away? Because this is another way you can tell if it has imaginary roots. What do we know about g of x? This is on page 106 or 107. It's a vertex form. So if that function's in vertex form, Jayla, and you don't have to know it right away, hopefully you know it, but what features should we know immediately if it's in vertex form? Yeah, not a trick question, right? Do you know what the vertex is here? -2, comma 1.
Teachers, please excuse this interruption. Any senior that has an appointment for FAFSA Frenzy, that location has been moved from the theater to the library. The library is closed today. The only people that can see the nurse is for emergencies. Thank you.
Anybody want to add on to or push back on the vertex being -2, 1? It's not negative? What is it? So +2? Jayla, do you want to make an argument against that, or? That's right. X minus h squared plus k. We do want to remember that. I want the opposite. Okay? What else do we know about this parabola if that's my vertex? Well, it has imaginary zeros. How do we know it has imaginary zeros? What else do I know based on that form that tells me it has imaginary zeros?
Concavity.
The concavity. It's concave what? Up. Because I would point out, if it was concave down, would it have imaginary zeros? Bless you. No. Like, if it was concave down, it would still intersect the x-axis. It would have real zeros. It's concave up, so it has imaginary zeros. Now, don't forget, if we have vertex form, what are we going to do to solve that quadratic equation? Once we get vertex form, what do we do to solve? Inverses with properties of equality. We've got to remember that. Okay, so we did that a little bit, I believe, in this class yesterday. Or was that my other class? Did we do that one here?
No.
No? The other class? Okay. So, good notes. Okay, so let's do this. Just a couple of minutes. Let's get to our vertical surfaces. Let's solve this equation. Now, I do want to point this out before we get started on solving, because I think some of us got stuck on this with the understanding check yesterday. This was originally a function. How in the world did it become an equation equal to 0? It was originally a function. How did it become an equation equal to 0? Well, what are we solving for in A? What does it talk about? Whether it's...
Zero.
If what are real or imaginary? The zeros. Remember, zeros are connected to x-intercepts, but more importantly, because if it's imaginary zeros, there aren't x-intercepts. What is 0? Why are we talking about zeros? We got to know this. what are the zeros? What is 0, I guess, is the better question. Okay, we have x minus 2 squared plus 1. It was equal to what? G of x. So what became 0? G of x. G of x, does that stand for x or for y? When we talk about zeros, when we talk about x-intercepts, what do we know about every x-intercept that has ever existed? That is why zeros are called zeros. Anytime you hear someone talk about zeros, we're talking about y equals 0. You've got to note that. Anytime we're talking about zeros, what we're talking about is y is equal to 0, so we let g of x, y equals 0. That's why this equation is now equal to 0. What are your questions about that?
Why you just change it?
Well, it's not just that we're changing it. What we're saying, if I ask you for a 0, the statement is that y is equal to 0. That's why it's called a 0. So I substitute 0 in for y, which remember g of x stands for y. Y is just the output. So it's not just like magically changing it. That's why the language is important. The fact that I'm asking for zeros tells you that the y is 0. So you substitute that in and solve. Okay? So anytime you're asked for zeros, what is the y value, Z? You with us? Do you know what to ask? Do you know what to ask? If I'm asking you for a 0, what do we know the y value is, Z? Think about just the words in that statement. It tells you everything you need to know. If I am asking you for zeros, what do you know the y value is? Well, y is always y, but if I'm asking you for a 0, what is the y value? 0, that's it. So we substitute 0 in for y, okay? Got to start there. So let's get to our vertical surfaces. Let's now solve this equation to figure out the zeros for this quadratic function. Come on, we got to do 2 to 3 minutes to solve this. Go for it. Come on, up, move, let's go. We got to wake up. We are too dead. Move around, go to your vertical surfaces. X minus 2 squared plus 1 is equal to 0. Go quickly, we got stuff to learn. Don't forget, Naisha, you can just hit the little button to the right. There you go, that one. Yep. So make sure you're actively working with each other, helping each other figure this out. If you have questions, ask those questions. I was saying, guys, come on, we got to get that equation written up there. People are already starting to solve it. We don't even have our equation written up. Come on, Marshall. There we go, Phoebe. Yes. Work on it over here on the right-hand side. You already have an appointment set up? You can go check, but I'm pretty sure you had already signed up. So make sure if we're solving, we're all in agreement with our group. So subtracting 1, yeah. Okay, just making sure. I want to make sure. She said she would have already said something. Yeah, so make sure we're actively engaged in that thinking and learning process.
Like, you guys need to end it. Like, you I agree with this. I went to that job 2 days in a row too. Like, I'm work because I need to.
I said, look at the thing about that language that's confusing. He's saying I is the square root of negative 1, right? So if you have the square root of negative 1, what can you substitute in for it? You just substitute I for that. Okay, there's some more things we need to think about with it, but that's a good start. So show that 0, right? Mark through your 1 minus 1, show the 0. There you go. Remember, when you have vertex form, you're going to use inverses. You're trying to solve for this x. What's the next operation to get rid of stuff to get closer to that x?
or lost count.
When you have vertex point, take that square root. Okay?
Are we done?
So that'd be what?
I'll add my 10. Wait, teach me how to do
Now be
this.
careful. We want the inside
All of me four
versus the
boxes.
square root. There you go, x minus 2 is equal to.
No,
Is there a way to rewrite that? Well, okay, so first off, you said what? But is there a way to rewrite that square root of negative 1? The whole point is that that is I, right? There you go.
So what you gotta do?
You're making it harder than it has to be.
Cause I don't know how to do none of it. Cause I
One thing I want to caution y'all right here. Same thing with this group. So both y'all. Do you know what you're gonna get docked on because you're missing a key detail? It's right here that I'm missing it. I mean, got the plus or minus here, and I would prefer that plus or minus, but something else. Right, and so you added, so I see the plus 2 over here as well, but if I'm looking for that procedural and conceptual understanding, I expect you to show that property of equality and showing that table.
Come here, come back. We're not done speaking. Go back.
I thought we was.
Well, notice the positive negative in front of the You're only adding 2. 2 on its own is a positive. What you took the square root of is positive. Okay? Yeah. Alright, so let's talk through this. A couple of ideas that I definitely understand where we are having questions, and that's totally okay. So, 2 things that I want to address. Oh, and I will say, this group over here, you are correct. The plus minus there, you would have to carry that down, right? So it'd be like that. So here's a couple of things I want to point out. And we got to be careful about this. We seem to be getting better at recognizing, hey, we have the square root of -1, and what is the square root of -1? That's I. Right? That is I. We got our positive and negative. Now, I do want to point this out. Here's a difference. The only reason we get a positive and negative is because we took a square root of both sides. If I just ask you what is the square root of -1, that in and of itself is only a positive I. It's only because you took a square root that you get that plus or minus. That's the only time you do that. Okay, it's when you take that square root. But right here, what's happening right now between the 2 and the I? They're being multiplied. Is this being multiplied right now though? What's happening? They're being added, right? So we want to pay attention to the fact that those aren't being multiplied, so we don't want to multiply them here. We're close to the right answer. Over here, I do want to point this out, right? We did pretty well, but look at this. Right here, what is the positive and negative on? It's in front of the what? Square root, right? Because when I take the square root is when I get a positive and negative. And so what I should have is a positive negative I plus 2. Are we adding and subtracting 2? We're not multiplying. Remember, we just said we're not multiplying, right? What are we doing with that 2? We had to add 2. So what should I have? Just plus 2. That's it. Now, we traditionally do switch the order, but even when I switch the order, is the positive negative on my 2?
No.
No. It's just 2. The plus minus is on I. That means the same thing. The positive and negative comes about because of what I took the square root of. So, when I look up here, the positive negative is on the I add 2 to it, so I would write it as 2 plus or minus I. What questions do you have about that? Aisha?
When we write our answer, do we put x equals, or we just leave it
Yes,
like that?
you would need to say x equals because those are solutions, right? Or they are zeros. Yeah, and that's the whole point, x equals. Questions, comments, concerns at this point? Do we understand how to fix it? Y'all see that? Okay. Okay. So, we are now looking at number 5, considering this function h of x. I'm going to step you through just the first couple of details that they're asking us about. Notice they do say what is the most efficient method to determine the zeros here. Talk with your group for 30 seconds. What methods could we take advantage of to determine our zeros for number 5? So this is the bottom of page 107. Just 30 seconds. What methods could we use to figure out the zeros?
That was my first guess. I was just saying still. I don't know.
Number 5? No, 107. Number 5, page 107.
Which one says zero?
Okay, so what strategies do we have available to us? Can we use quadratic formula here?
Everything, right?
So, quadratic formula, what are the requirements to use the quadratic formula?
Has to equal to 0.
Has to equal 0. So I do want to point this out. Looking at that function right now, does that function equal 0?
No.
Sure about that?
Well, it could.
What does it ask for? It asks for,
H of X.
it asks for what for h of x though? Say it again, Ethan.
determine 0.
It asks for zeros. If it's asking for zeros, what could I substitute in for h of x for the y? 0. Okay, so could I now use quadratic formula?
Yeah.
Yes? Okay. I heard someone say that we could use any method, right? I could definitely use quadratic formula. That will always work. What about the vertex form? Can I easily figure out the vertex form in this case? What would I need to look at to figure out the vertex form?
B and A.
Say it again.
B and vertex.
I would need to use B into A to figure out what though?
H.
Is that true? H? Remember for that vertex form, we need A times x minus h squared plus k. And how do we calculate h?
Negative B over 2. Oh,
Negative B divided by 2a. Well, what would that give me looking at h?
1.
1. How'd you get there? Give me a little bit more steps for those who didn't quite jump there to 1. Preston, you with us?
Positive 2 divided.
Okay, so the opposite of b would give me a positive 2 divided by 2 times 1. That gives me 2 divided by 2, which is 1. Alright, there's my h. Is that a nice, easy number to work with? So does vertex form a good option?
Yes.
Okay. And I do want to point this out because this is an issue I saw in our understanding checks. Have I done anything to use my inverses, like subtracting 2 to get rid of it on the right-hand side, and then subtract 2 on the left-hand side? No. Remember, guys, you cannot solve a quadratic in standard form. You can factor it, you can convert it to vertex form, you can use quadratic formula, but you cannot solve it in standard form. When I look right here, I did hear someone say zero product property with factoring. Can I use that method here?
Yeah.
Have you checked?
Oh.
A times C is 2, right?
Well, yeah, negative 1. Oh, I lied.
What are factors of 2 that add up to negative 2?
No.
None of them? Not at all? Yeah, nothing works. So can I factor and use the zero product property?
No.
No. Now remember I told you this earlier. How could you have figured out, and I'm going to tell you there are imaginary zeros here. How could you have figured out that there are imaginary zeros for h of x? What could you have done with h of x to figure out there's imaginary zeros? You can graph it. If you graph this function, there are imaginary zeros. That's an important thing to notice here. But B gives us another option. It says determine the discriminant of the function. How can you use the discriminant to know whether the solutions are real or imaginary? So they define the discriminant right here. The discriminant is b squared minus 4ac. Anybody recognize that?
Yeah.
Where's it from?
Quadratic formula.
Yeah, the quadratic formula, guys. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Well, let's look at b squared minus 4ac. Just that. So what is my b that I'm going to end up squaring?
Negative 2.
Negative 2. Now be careful, not the x. Remember, b is not the x. b is just the coefficient of that x. So just negative 2. If you put variables into this equation, it's going to mess you up. Just the negative 2 squared. Minus 4 times
1,
times 1 times
2.
2. Any questions about where I got those values for the discriminant? So, pick up a calculator. What is the discriminant then?
-4.
It's negative 4. Can I get verification from somebody? Hopefully everybody, because we all picked up our calculators, right, Marshall? Interesting. Let me ask you a question. Lily Kay, be careful about this. Did you put a minus here, or did you put a negative here?
Minus.
You sure?
Yeah.
Did you click the number or the symbol next to the plus, or did you? So my guess is, yeah, see right there? You actually hit the negative. You hit that instead of that. And so you see how I put a multiplication symbol in there? Now for this one, you put a 1 instead of, yeah. So be careful with it, guys. Alright, so here's the thing I want you to think about. That discriminant, that radicand is negative 4. So that means I get the square root of negative 4, which tells me I have what type of zeros? If I get the square root of a negative, that's imaginary. That's the whole point. And so if your discriminant, if discriminant is is negative, zeros are what? Are imaginary. So you now have two strategies to find out if your zeros are imaginary or not. So if your discriminant is negative, just that b squared minus 4ac, if that is negative, then you have imaginary zeros. And so, at this point, we need to actually solve and find our zeros. I believe part C is on the next page. And so we know we have imaginary zeros. We know what are the two methods we can use to solve this quadratic equation. Quadratic formula or vertex form. I don't care which method you use. I want you to actively work with your group to use one of those methods to solve this quadratic equation. So let's get up, let's move to those vertical surfaces, and let's actively collaborate, help each other grow and learn. You're actively engaging and thinking. Hard to grow and learn if you're not. Hey, you awake over there? Come on. Head down, sleep mode is not going to help us.
No.
So what's our strategy? What are we thinking? Press. Which method are we going to try to use?
Imaginary one.
It's not a method of solving quadratic equations. What method? What are the available methods to solve a quadratic equation? So remember with factoring, right? AC method of factoring with the zero product property. You got to say all of that if you want to think through all that. Can we factor in this one? Okay, so that's not an available method this time around. So what is available? Quadratic what? Formula, and converting the vertex form with our inverses, right? So which method do we want to use as a small group? Alright, so let's do it. Okay. By the way, if we agree, David made a decision. All four of us need to agree. Come on. Oh, we already. Okay, pause 1 second. I just want to scoot over here so we can easily see this, right? Do we all agree with this work or have any questions that we need to ask? You agree with it? So you understand, how'd you get H? Or actually, how did you get K? Well, what is this letter right here?
I'm tripping.
Okay, but how'd you get that? That's that's something.
I took it from the way this is.
Oh yeah, I guess we did. Okay, but we don't want to just take it. We need to make sure we understand how to get H. Do you understand how to get that H there? That's how we always calculate H. Okay, so we've got to recognize if we're trying to convert to that vertex form, we have to start with that negative b divided. And I would want you to show me that for me. But yes, that's the same exact H. You get with that idea? And so how did Naisha then get K? Because it's the same pattern, same form every single time. Right. Remember, H is the input of the vertex, K is the output. So we just substitute into that expression, right? We now have H, we now have K, and we had A from the beginning. It was that understood. We good? All right, work with each other to solve from this point. Okay?
This Friday.
How's it go?
This is what I'm seeing. Oh, I thought you said
When you hit them. Oh, y'all hit them? So one thing I would point out is the division has a distributive property, just like multiplication does. So you could divide both of the numerator values by 2. 2 divided by 2 plus or minus 2i. But it looks like we're a little stuck right here. So you're trying to do vertex form. So let me remind you, because like this one of the issues, a lot of students just start here, but like, what are you trying to calculate with that? So write that. That's why I also write out my vertex form to get started. So, anyone know what this A is already? We all know how to calculate that H. Okay? Make sure that we think through when we put the 2 together. It's not just about 2, it's 2A, and we get 1 at the end. Okay, so what's the only thing I'm missing? How do we find K? Remember, H is the what part of the vertex? Yes, it's the X, but it's also called the input. H is the input, K is the
Oh, what you mean like?
if you can remember that link, that's why the input is important. So in the input of the one, I'm just substituting that in for X.
I did, I was just job 2 days in a row. Well, yesterday, they said like, he's gonna be there for 5.
And now I can get the vertex with that. A was
That's what he said.
times X minus H plus 1 squared plus K is equal to. There's actually converted from standard form to that vertex form, so it's still equal to 0. Can I solve that equation?
Yeah.
Give that. Okay, Marcus. Marcus, check out the others. Alright, working from there. Let's solve it. So what did you get? Let me ask you a question. How do you subtract 2? And why? Let me ask you an important question to remember. What are the methods to solve a quadratic equation?
What? Law, you just said 108.
Are
you weak?
Okay. Because if I already have factor form, I'm going to try to use this for product solving. If I already have vertex form, we're going to use it. And so I want to remind you,
It happened a while ago.
you can convert it to vertex form.
Like, I told you,
I just said, if it's vertex form, I can use it.
So I say that to joke. No, but tell me, look. So that friend I was talking about, I showed him the message to me, and he's seen already previously that I don't text him back. Okay, keep that in mind. So he was like, but look. So he said he was like, so I sent him the screenshot and he saw where I said that. But I'm thinking I'm not covered up because he sent the message to me. I don't like that. Nobody told me. And he was like,
right? And if I look at this,
Damn, I was like, what if I go to this wine? I drink around. It is because you
So is it where the actually need to go that I? But I would never actually do that. Like that's like he's
Alright, ladies and gentlemen, let's grab a seat, let's talk through this, and then I'm going to give you your understanding check back for about 10-15 minutes to work on it. So here's what I want to remind you, and this is probably the most common mistake that I see students make, right here. They look at this quadratic equation, and then they subtract 2. What are you trying to use if you're subtracting 2 from both sides of that equation? Inverses with properties of equality. What is the only form of a quadratic that you can use inverses with properties of equality? Vertex form. Do not forget that you can only use the inverses like this to solve if you have vertex form. What form did we currently have? Standard form. Okay. You can only use those inverses if you get to your vertex form, and so we can't do that yet. But some of us very successfully converted to vertex form, right? We wrote out, or I recommend writing out, because we got a little stuck. We calculated h here. Start here by writing this out, and remember, okay, I need a. A is 1. I needed h, so h is always equal to negative b divided by 2a. And I calculate what h is. Once I figure out what h is, how am I going to figure out k? Because that's the only piece left. Substitute h in. Does anyone remember another word for h that should tell us to substitute it in? Yes, it's an x, but I'm focusing on the idea that we want to substitute it in. Because h is the input for the vertex, and k is the output. Notice right here, it was x squared minus 2x plus 2. And we substituted that 1 in for x. And when you substitute that in, k ends up equaling 1. So 1 times x minus 1 squared plus 1 is equal to, that's it. That's how you use your vertex form. Okay? And then you have that vertex form. Now I can use my inverses. I show the creation of my zeros and of my 1s. Right? But when I take the square root of negative 1, I end up getting I, and we successfully did 1 plus or minus I. What are your questions about using that vertex form here? Group 7, I'm now just seeing that y'all got a little stuck. Does that method make sense? Do you have a question, Jose or Preston? David looks like he's okay. Yes, no, maybe so? Okay. Please notice over here, this group very successfully actually did the quadratic formula first, right? Guys, the quadratic formula will always work as long as your standard form is equal to 0. And so I would have liked to have seen everything substituted in right away before things are simplified, but the opposite of b. b is negative 2, so what's the opposite of that? 2. Plus or minus the square root of negative 2. Notice how I put it inside of parentheses. If you don't put it inside of parentheses, you will get the wrong answer. Now, I can still see that you understand the majority of it and you'll be okay score-wise, but put that negative 2 inside of parentheses. Minus 4 times, what is A? 1 times C, which is 2. All divided by 2 times 1. Now, I'm guessing you had the negative 4 from when we did the discriminant earlier, but do show me that extra step. And notice that he then just simplified it to here. Square root of negative 4. As soon as I see a square root of a negative, what number am I thinking about? I. That imaginary number, right? And what's the square root of 4? 2, so I get 2i. Don't forget, you can take the extra steps. I recommend it, of rewriting this as the square root of. If I'm dealing with a negative 4, what number should I immediately think about? I'm going to try to get to I, but what number do I need in my radicand to have I? I want that negative 1. Negative 1 times what gives me 4? 2. Negative 1 times 4, right? I might have said that slightly incorrectly, but and if I did, I apologize. That just gives me a square root of negative 1 times square root of 4. Square root of 4 is 2. Square root of negative 1 is? Square root of negative 1 is?
My bad.
I.
Oh.
So we get 2i. Notice we can then simplify. It's not just magic that we get this here. If we distribute that division by 2, which we can do, 2 divided by 2 is 1. 2i divided by 2 is 1i. And that's the same exact answer we see from the vertex form. Please do note that detail. One last thing I do want to point out before I give you your understanding checks back or give you time to work on your understanding check is this. That's not pretty, okay? More than likely, not factorable, I haven't checked. Vertex form would be actually awful. So I would want to use the quadratic formula. Can I use the quadratic formula right now? Naisha, you instantly shake your head no. Why? Remember, to use that quadratic formula, the equation has to equal 0. To factor and use the zero product property, the equation has to equal 0. So in general, with quadratic equations, you want that equation equal to what? 0. What could I do to make this equation equal 0?
Add 4 to both sides.
That's closer, right? But now I have 3x is equal to 2x squared.
And then subtract 3x to both sides.
Would that create a 0 right there?
Yeah.
So I bring this up because you got to keep that in mind. The only time when with standard form that you would use inverses is if you actually want the equation to equal 0. I need you to pay attention to that. The only time in standard form where you would use inverses is to make sure that equation is equal to 0. Questions, comments, or concerns before we start? Back. Okay, clear your desk. Alright, Cam, Marshall, Ethan, Naisha, Eliza, Jamarcus, Jacoby, Jose, David, come on, Justin, get that up.
I almost like just broke down.
Shania,
But you make me feel really bad now.
Desiree,
But I apologize.
Jayla, and Lily Kate. For the rest of us, you have the 10 minutes or so at this point to work on your understanding check. Let me find them. There they are. Ready? No, not right now. This is time for you to update it as you want before we start going over it. So, silently working on our understanding checks as much as we can for the next 10 minutes. Who needs a copy? I will say numbers 1 through 3 should go by pretty quick. I would knock those out and make sure I have those. Pencils need to be completely off the desk before you can get out of color pen if you have one of those. Pencils need to be completely off the desk before I go to the first couple questions on here, or it will be a 0, so make sure the pencils are completely off the desk. Okay, so I'm going to show you the answers, maybe a little bit of notes, but I want you to ask what questions you need to ask about how we get there. This is a learning opportunity. Your test is the final assessment on these skills. So what questions do you have about these answers? Eliza, I'll start with you, and then Tyson, I'll go to you.
Number 2, I thought like you had like 5 times 15 equals negative 35. So like what would be 5 times 15?
Great question. Okay, so 5 times 15 equals 75. It does. I'm assuming you had a negative 1 in there somewhere. Okay. So can anyone tell us where I got the 5 and the square root of 3? Kind of. Yeah, you could look at that 15 again, and you could actually rewrite that 15. How could you rewrite that 15? 5 times 3? Okay. So this is a roundabout way of getting there, Eliza, but you can do it this way. Right? Notice how you have 5 times 5 right here? Isn't that the same thing as 5 squared? And so you can actually literally rewrite this as the square root of 5 squared times the square root of 3 times the square root of negative 1. And what's the whole point of a square root? To find out what? What was squared. So literally what was squared? 5. That is a long way. I agree, but this is based off of what Eliza did to still get there, right? What was squared? 5 was squared. Can I take the square root of 3? Like, is that going to be a nice rational number? Okay, so that'd be square root of 3. And what's the square root of negative 1? I. Okay. Now, I will point this out. That was not the strategy I used to get there. You can still get it there that way, Eliza, but you went to the 5 and the 15, and that's kind of what got you in a little bit of trouble. Who had maybe a more efficient method of getting there? Why did you look at 25? So, when I look for factors, I want to look for factors that are perfect squares. Meaning, I want to look for 2 squared. I want to look for a 4. I want to look for a 9. I want to look for a 16. I want to look for a 25. I want things that are perfect squares. Does that make sense? And that would be a much more efficient strategy in this case. So square root of negative 1 times the square root of 25 times the square root of 3. And I would just rearrange it so that my I is at the very end. Square root of 25 is 5 times square root of 3i. Tyson, did that answer your question? Okay. I do want to point out, do I have an x equals anywhere here? Nope. Was I solving an equation? Nope, so I don't introduce an x. Do I have a plus or minus in this case? Or a positive and negative?
Yes.
Do I have it written up there? Well, you're looking here for that square root of negative 1, and you're looking here, but I'm talking about in my final answer, did I have a positive and negative? Nope. Because remember, what creates that positive and negative? It's when you take the square root in an equation. It is only when you take that square root that you get a positive and a negative.
Can you say which one is on the
There's at least 2. But you will also have to simplify radicals if they show up in your solutions, right? And these are easy points that we want to make sure we get. I know it seems harder at first, but this is only the first couple times we're really looking at it. I would practice these. And here's the thing, the way you can practice this, make some up. Square root of, what would you need to look at to practice getting that imaginary number? You're always going to need a negative. Try square root of negative 81. Try the square root of negative 64. Notice I use perfect squares there, right? Then start just making up other numbers. Maybe the square root of negative 32. You make any up and you just practice with it. Okay. All right, any other questions for 1 and 2? It's a great learning opportunity. Active collaboration matters.
Can I do one of the hands right here?
The pins?
Yeah.
You don't like the color markers? I have some over here. You can grab one from the over on the other side of my desk. Actually, I have some.
I see him back here, Mr. Kenny. He goes on.
Yeah, but those aren't opened yet.
Oh, okay.
That's almost broke that. You can use this black pen. I had a purple one, but I don't know where it went. That's an easy one to access. Okay. No problem. Okay, so looking here at number 3, what questions do you have here? So which of the following functions would have imaginary zeros or roots? Any questions about this? I do want to point out, based on, and so do note, like I noted things like the double root, 2 real roots, because that's going to provide greater evidence of understanding. That's how you get to those 4s and 4 pluses. One thing I saw students make a comment on yesterday was they said f of x has imaginary roots because it will not intersect the y-axis. 1, is that y would have imaginary roots, and 2, is that a true statement? It's only about x-intercepts, right? But 2, is that a true statement that f of x is not going to intersect the y-axis?
The Y is false.
It's a false statement. It will intersect the y-axis? At some point. Not just at some point. I can actually look at that equation and tell you right away where it'll intersect the y-axis. Then you need a little bit more. Remember, that's standard form, right? C is that y-intercept. I can't see it yet because it's so far over here, but notice, is it still going to go up and to the right? Is it going to keep going over until it gets to that y-axis? Yeah, it's just really far away. Any questions about that? Going once. Going twice. Remember guys, these are good learning opportunities. Learn from the mistakes, learn how to improve, ask all the questions. Jalen, you with us? I don't think I've seen you look up at the board yet. Come on. It's hard to learn if we're not even actively looking at the board. So number 4, I made the quick note here that I'm using the quadratic formula for sure. And these are the solutions that I got when I used that quadratic formula. What questions do you need to ask?
So why wouldn't that be 3 plus or minus 2i?
3 plus or minus 2i. Ah, so did you get to this point? Right here? Okay. So remember, division has a distributive property, right? What can I divide everything by? 2. And so if I can divide everything by 2, that's what I need to do. And so I would do 6 divided by 2 is 3, 2i divided by 2 is I, divided by 4 divided by 2 is 2. So I divided that common factor of 2 by everything, right? So if you got to here and you made that small procedural mistake here, that's a 3p plus as long as everything else is well justified, right? But you would have to divide everything by 2. What you can think about it as is 6 is 2 times 3 plus or minus 2 times I divided by 4, which is 2 times 2. See how everything has that factor of 2? And so I'm dividing everything by 2. And that's how I get left with 3 plus or minus I divided by 2. Okay? Do I need to address why I would be using the quadratic formula here? Okay, but here's an important question, Miracle. How was I able to use the quadratic formula? Because what's the one requirement for quadratic formula? Miracle?
I don't know.
Talked about it a few times today, and we got to know this, otherwise we can't use it. So let's get someone to help you out, and then I'm gonna come back to you. Preston, what's the one requirement for the quadratic formula?
Has to be equal to 0.
Anybody wanna push back on or add on to that? Okay. One thing I would remind you is it has to be the standard form that equals 0, right? So, Miracle. If you look at k of x right now, is it equal to 0? Is k of x equal to 0? No? So how did I use the quadratic formula?
What's the comma shift equal?
So how did I get, that's just saying, hey, x was equal to this once you simplified, so I then got to here. How did I use the quadratic formula if that joker's not equal to 0? I'm asking for what? Roots. I'm asking for zeros. And what do we know in order to get those zeros? K of x is equal to 0, right? Your output, your y, is equal to 0. You can't just magically do that, but if I'm asking for a 0, that's literally what I'm asking for. We gotta know that. Come on, Miracle.
Can you put the 0 like at the end of it, or you have to put it in?
I mean, so if I were to say x equals 3 and 3 equals x, does that mean the same thing or different things? Same thing. So you can always switch the order of the equation. Does that make sense? So I did it with a simpler version, but yes, you can switch the order. It won't change anything though, right? That standard form just has to equal 0. I did it that way because k of x was already in front there. Okay? Can anyone tell me why I said quadratic formula for sure? Why I did not try vertex form here?
Fraction.
What would be a fraction?
H.
Yeah, if you check h, right? Opposite of b divided by 2a. What's the opposite of b? Positive 6 divided by 2 times a, which is, well, a is 2. So I get 6 divided by 4. Yeah, that's 3 halves. I literally did it. And I was like, yeah, no thanks, I'm out. I'm not using vertex form here. Could you? Yes. But you're going to have to deal with fractions, and I'm out. The quadratic formula.
The interruption again. As luck would have it, the FAFSA website is not working this morning.
Nice.
So if you are a student that wanted to complete their FAFSA this morning, we are going to have to postpone it. If you are a student that is submitting a waiver, which means you will not complete the FAFSA at this time, you can submit those in the theater, in the library when the bell rings. Every senior has to have a checkbox in Power School saying they have either submitted a waiver or completed the FAFSA.
And so I need to emphasize this. Guys, the quadratic formula is the method that if you can't do anything else, you should be able to do quadratic formula. What do you have to do for the quadratic formula? What's going to take a little bit of time and effort? You got to memorize the formula. Wait, there's no ands, ifs, buts about it. Quadratic formula is one, can someone let Rakai in, please? Quadratic formula requires memorization. You gotta make sure you know that formula. Write it out, create a flashcard, create a Quizlet, something. But if you can memorize that quadratic formula, you can always use it. And I will tell you, like on your test, you cannot earn full marks to show me mastery unless you use all three methods. But can you use the quadratic formula over and over and over again? Yeah. Does that show me some level of understanding? Yes. I want to see AC method of factoring. I want to see vertex form. But remember, the only requirement is that you use each method at least once, and then you choose on the other 3. Then here on number 5, here are the solutions. I will note here, what did you have to do first? With number 5? I made that left side equal 0. Now I will clarify. Could I have made the right-hand side equal to 0? Yes. Would that have been as fun? No. Right? I'm going to take the path of least resistance. And yes, it's a crazy thing where you can actually do both those steps at once. Right? If I do 3x minus 3x, what did I make? Negative 5 plus 5. And I just add my like terms. That's how I got this 0 equals x squared plus 8x plus 43. Notice I didn't require you to use one method or another. You could have used either one. We need to be careful with our notation though. Everything is being divided by 2. And we need to be careful with substituting in, and we've got to make sure, I think, notice you need to subtract 3x. Show your inverses on both sides. That's what messed you up there. Right? Yes. You started on it yesterday, though, didn't you? All right. So we have about 2 minutes left, so I'm going to quickly work through this one. Show of hands, would you prefer vertex form or quadratic formula? So raise your hand for vertex form. Quadratic formula. Most of us just don't seem to care. All right, let's do this quickly, both of them. So opposite of b gives me -8 plus or minus square root of 8 squared minus 4 times a was 1 times a c of 43. Man, that is hideous. Divided by 2 times 1. Please notice how everything is being divided by 2a. Not just the radicand, not just the square root, everything. That fraction bar goes all the way through. X equals -8 plus or minus the square root of, and I would have just put this into the calculator, but that gives me -172. -8 plus or minus the square root of -108 divided by 2. Now you could have technically left it here and earned the majority of credit, but when I look at 108, I think about 36 times 3. I did that because the square root of 36 I can actually do. -8 plus or minus, that would give me a 6 square root of 3i when you work it out. And that would give me -4 plus or minus 3 square root of 3i. That's what x is equal to. I know that was quick, but there's that work. H is equal to -8 divided by 2 times 1 is -4. K is equal to -4 squared plus 8 times -4 plus 43. X is equal to 27, or K is equal to 27. Have a great rest of your day. We will review for 45 minutes tomorrow, and then we'll start on the next unit. Take advantage of, yes, hold on to, ooh, actually I do need that back so I can make scans. Sorry, I need your understanding check. I will quickly make scans of it and give it back to you tomorrow. Thank you. Thank you. One thing to mark is be careful, right here. That would be times 100, right? -1 times 100. And then that would give you the square root of -1 times the square root of 100, which is why we did 10. And then we get 9. So you had the right answer at the end, because I think I went ahead and took that square root. But you can't take the square root until you get to there. So you have like the right answer, but you would get hit on procedural mistakes. Even though I can see it, but like you're making, be careful with that, okay? It's once you get that square root of 100 on its own, then you can take the square root. Good morning, Savannah. And Savannah.
I didn't know where.
I don't even know where.
I'm so stupid. Hold on 1 second. There we go. Alright, wow, we got everybody in already. Good morning, Tristan. Yes, sir. Good morning, Ireland and Kaysen. In Ireland. Glad to hear it. Good morning, Jamarcus and Kanye. Chris. Good morning, Kanye. Yeah, you are. Good morning, Caitlin. You thought you just woke up from a nap. Gotcha. Thanks, Sam. Good morning, Kennedy. Yeah, you are. Good morning, Lucian. Yeah, you are. Good morning, Shatiria and Kaylin.